over the last several days now, coming up to the break and then after the break, we've looked at a couple of different two-dimensional collisions. The first one is when we had an object maybe going this way, colliding with maybe an object going this way. They collide, maybe they stick together and head off as one. Go off like this. We had a momentum to the north, we have to have a momentum to the north afterwards. A momentum to the west, we have to have a momentum to the west afterwards. We can analyze this problem, right? This is no different than analyzing two one-dimensional problems. We would say x, which is the horizontal problem, and y is the vertical problem. Pi is equal to Pf for both of them. We would say 0 plus m2v2i. How come 0? Why is it 0 plus m2v2i? There's two objects, right? Don't we say m1 v1i plus m2 v2i? Well, we could, but what's v1i for the x component? Yeah. How much of this object, number one, is moving horizontally? None of it. So we're going to say it's 0. Equals, well, let's say m total times vf. Solve for vf there for the x component. And then we go and do our y component. For this one, we'll say pi is equal to pf again. This one would be m1 v1i plus 0, because object number 2 is only moving on the x-axis, not on the y-axis, equals m total times vf. Solve for vf. And then we just put them together, right? We say vf x component, vf y component, and then we combine those to solve for the hypotenuse, which is going to be found by doing the Pythagorean theorem. The angle found by the inverse tan function. Make sense? Okay, we've done some of those problems now. We've done lots of those problems, really. We just haven't necessarily combined x and y. We've done either x or y, and then we've done some with x and y. Okay, they're not really any different. It's just twice as much work, that's all. Yesterday, however, we were introduced into problems where it was two-dimensional like this, where we had an x and a y component, but it wasn't just x or y for each object. It was x and y for each object. In other words, there were funny angles. So we had a situation maybe like this, where an object exploded, one piece goes this way, and then another piece goes this way at an angle of 30 degrees. And then the third piece maybe goes up this way or whatever. What's different about this? Well, the angle, the funny angle. If we have a funny angle, and that's what makes it different, then let's take that funny angle off to the side and get rid of it. This is 10 meters per second, let's say. Then we take it off to the side over here, label it as 10 meters per second, label an angle of 30 degrees, and then we solve for x component and a y component using sine and cos. By the way, what trig function would we use to solve for the x component? What trig function do we use to solve for the x component, Jack? Yeah, it's cos, because it's the adjacent side. Cosine 30 degrees is equal to x over 10. And then we'd say sine 30 degrees is equal to y over 10. And then what I like to do, at least, is just kind of box that off. Take it off over to the side, box it off. And that box just kind of reminds us that this is what makes the question different. Now that we've boxed that off to the side, we do exactly the same thing as we did in this question. This pi is equal to pf. We don't have to worry about a funny angle now because it's gone. And we said yesterday, it's dead to us. This 10 meters per second, really, if we want to, we can redraw it as something that looks like this. 10 meters per second, it's the same thing, except now it has an x and a y as opposed to some funny angle of 30 degrees. Okay, so now we'd say x component, pi is equal to pf. Pi would be 0 because this object is at rest, equals m1 v1f plus m2 v2f plus m3 v3f. Several values in, using the x component here of that second object. And then we do the same thing for the y components. Solve for v3f, and of course, do what you did before to combine them using the Pythagorean theorem in the inverse tan function. Does that, in theory, make sense to us? We did an example with that yesterday, and we assigned one question for homework last night, question number 4 on worksheet number 4. We're going to take a look at that in just a second. But before we do, I want to just make sure that it's at least makes sense. Not that you can necessarily do it, but that it makes sense to us. Okay. What makes this different from this? What makes question 2 different than question 1? There's really only one important thing that makes question 2 different than question 1. Right? What makes it different? What's boxed off to the side. We have a funny angle of 30 degrees. Get rid of it. Once we get rid of it, then we have the blue X and the green Y, which is exactly the same as we have right here. All right, I want to take a look now at worksheet number 4, question number 4. That's the one question that you had for homework. I'm not going to bother giving you an answer for that because we're going to go over it here anyways. Once I find the question here we are. So the question says a 400-kilogram bomb sits at rest on a table and it explodes into 3 pieces. Here's my explosion point. It says the 150-kilogram piece moves off to the east. I'll call that piece number 1, although it doesn't really matter whether you call it piece number 1 or piece number 3 or piece number 35. It doesn't really matter. I'm calling it piece number 1 because it's listed first. It has a mass of 150 kilograms. It has a velocity of 150 meters per second. Another piece moves off south of west. This is 100 kilograms. What is it, 30 degrees south of west, 100 kilograms, and we've got a velocity of 200 meters per second. And what's the velocity of the third? Where's the third piece going to go? What's your best guess on that? What are you saying? Yeah. I'm going to guess it's up and to the left as well. In the end, I know that it's going to be up. I know that it's going to be up. There was 0 momentum before this explosion took place. There's 0 momentum after this explosion took place. To have 0 momentum after, and having already established that there's downward momentum, well then I must have upward momentum to cancel that out, to give me 0. Now, left or right, we have a left momentum and a right momentum. How do we balance that out? I'm not sure whether this should be up and left or up and right. But you know what, in the end, it doesn't really matter. The first 2 vectors that we have drawn here, we have to have those drawn correctly. The resultant vector, it's really only there to help us visualize it. If we guess wrong, it's not the end of the world. Okay, let's see what we can do here. Take off the 200 meters per second off to the side because, hey, we don't like funny angles, right? Let's make this our X, and let's make this our Y. And what was our angle? 30 degrees. Which trig function is our X component going to be found by? What is it? Yeah, it's the adjacent side, so it's cosine. We're going to say X is 200 cosine 30 degrees. And that works out to be, I want to say it's like 173 or something. What is that? 173.205. And then the Y component, well, that's sine, 200 sine 30, which is 100. Box it off. Why? Well, because that's what we do. It just shows us, reminds us that this is the only thing that makes this different than those other questions that we had been working on. What's the initial momentum of this bomb? What is it? It's at rest, right? Now, there's another question you're going to do, question number 6 in a little bit. It was moving. So if this was moving, we wouldn't say the initial momentum is 0. if this was moving, we'd say the initial momentum was m total times vi, m times v, right? But it's not, so we'll just write in 0. Pf is m1 times v1f plus m2 times v2f plus m3 times v3f. Man, I wish the masses were the same, because what could I do if the masses were the same? Yeah, cancel them out. I think that happens in question number 5, that happens. 150 times 150. But the whole thing 150 is x component, none of it is y, so let's have that in. M2 is 100. What's V2? What's V2? That's not 200. 200 is dead to us. What are we going to use? Well, either 173 or 100. Which one do you want to try? Read, which one is it? 173 or 100? For the x component. What is it? 173, good. We're going to actually make it negative because it's going to the left there. Plus M3, which is, what is mass 3? 150 kilograms? Okay, 150 plus 150 plus 100 is 400. I'm going to show more steps here than I did in my answer key. 150 times 150 is 22,500. And this is 100 times negative 173 is negative 17,320.5. So combine these, subtract them, take it over the other side by subtracting, and then divide by 150. And when we do, we get V3F for the x component is equal to negative 34. Now we got to do the y component. Let's pretend that's not there so we have some more space, okay? Pi is equal to Pf. We'll say 0, once again, is equal to, why am I saying 0 plus m2v2f plus m3v3f? Where did that second 0 come from right there? Yeah, like the initial velocity of object number 1, it says is 150 here, right? So why am I putting it as 0? Because what? Okay, but this first 0 is because it exploded from a standstill, right? Yes, good, exactly. We're looking at the y-axis now, and although it's moving at 150 after it explodes, it's moving at 150 on the x-axis, and we're just paying attention to the y-axis. This time, right up here, we paid attention to the 150 because it was on the x, but down here it's 0. So we're going to say 0 is equal to m2 is 100 kilograms. V2F, we're going to make negative 100. 100 because, well, that was the y component, but negative because it's going down. M3 is 150 times V3F. And when we solve for V3F here, it's a little bit easier than it was in the last one. V3F here is 66.667. So now we just say, what, 34.53 to the left, 66.667 upwards, and we're going to say V is equal to the square root of those, which gives me 75.1. And what about theta? Theta is the inverse 10 of opposite over adjacent That gives me 62.6 degrees. But what is it? North of east, south of west? What is it? This is north, this is west. We're going north and west, right? North of west or west of north? Where's the angle being measured from? From the north or from the west? Look, where is this angle being measured from? The north or from the west? It's being measured from the west, all right? It's north from the west. So we're going to say this is 62.6 degrees north of west. Okay, how many people got that? 75.1 meters per second at 62.6 degrees north of west. Hands up. All right, here's what I would like you to do. If this makes sense, I would like you to take a look at question number 5, please. It is very similar to number 4. In one sense, it's harder because there's 4 objects after the explosion, but in one sense, it's easier because it has equal masses. So those masses end up canceling out. Let's give it a try, see what you can do. We'll go for about 6 or 7 minutes to see how it goes for you. Okay, let's have a look at question number 5 now. This one says a bomb sitting at rest explodes on a table. 4 pieces, equal mass. I like it when it's equal mass because, listen, we know that when it's equal mass and conservation of momentum problem, we know it's going to cancel out because the mass appears in every term. And that makes life a little bit easier for me mathematically. We have 1 piece going to the south at 55 meters per second. I'm going to call that piece number 1. I'm not even going to label the mass. A, because I don't know what the mass is. B, because we know the mass is going to cancel out, so it doesn't really matter what it is. We got a second piece going to the west at 80 meters per second. Let's call that piece number 2, 80 meters per second. And we got a third piece going west of north. Now pay attention to this one. People will get this angle wrong a lot. This is west of north. Okay, so we're going north and we're going west. But west of north is right here. Right? Remember, that angle is measured from the north, of the north. But it's going west from the north, or west of north. All right, the fourth piece, honestly, we don't know exactly where that's going to go. Somewhere over here, probably. But you know what? That fourth piece, that's what we're trying to find. If we guess wrong where it's going, so what? It's no big deal. The first 3 pieces, we got to nail those. Okay, we got to get those in the right spot. That diagram has to be perfect for those. But the fourth piece, if we already knew exactly where it was going, we wouldn't need to do the question. So that's the whole point of the question, is to find out where it's going, right? Okay, we get piece number 3 that's got a funny angle, so I take it off to the side, put it out of its misery. 30 degrees right here. We're going to call this our x component. We're going to call this our y component. And our hypotenuse there, we already know is 40 meters per second. Now, be careful on this one. Man, it's easy to mess this one up too. We get so used to saying x is found by cosine 30 degrees or cosine whatever. Well, that's only because usually x is the adjacent side. This time x is the opposite side of the triangle. So which trig function area are we going to use this time for x? Right. Sine 30 degrees is equal to x over 40, or x is equal to 40 sine 30 degrees, which is 20. We're going to say y is equal to 40 cos 30 degrees, which that gives me 32 or 33, I forget which. 34, I guess it is. 34.641. Box it off, because that's what we do. This reminds us that it's what separates this question from a T-bone collision, right? The 90-degree collision. So it makes it different. Now we do our whole x component, y component thing. What's the initial momentum of this bomb as it sits on the table ready to explode? What's the initial momentum of this bomb as it sits at rest on the table, ready to explode that, Connor? 0, right, because it's at rest. Now, we've got 4 objects afterwards, M1 V1F plus M2 V2F plus M3 V3F plus M4 V4F. What can I do to simplify this? This is what I was excited about when I read the question. Yeah, get rid of the masses. And I can get rid of the masses, how come? Yeah, they cancel out, right? If they're all the same, if one thing appears in every term, and even though they're different masses here, it's the same values, the same value that appears in every term, then I can cancel it out. Now, if the left-hand side wasn't 0, that wouldn't work, right? But since the left-hand side is 0, dividing by the mass, whatever it is, including on the left-hand side, makes it disappear. So this is nice, especially where I don't have a whole lot of space to work, because I don't have to include any masses. 0 is equal to V1F. Oh, look, what's V1F? For the x component, what's V1F? 0. It's 55, but 55 is all going down, and we only care about what's going across right now. V2F is negative 80. V3F, here's the one that we got to really pay attention to. V3F, Dylan, what's V3F there? How much of that 40 meters per second is x? I'm going to cross this out because we don't want the 40, right? It's dead to us. It's the 20, right? Except we're going to make it negative because it's 20 to the left. Plus V4F. Okay, that's negative 100. Take it to the other side by adding. V4F is equal to 100. That's not a final answer, but that is our x component. Now we do our y's. Pi is equal to Pf. Once again, 0 because it's at rest. M1 V1F plus M2 V2F plus M3 V3F plus M4 V4F. Who told me the masses cancel last time? Who was that? Did the masses cancel this time? Yeah. Same masses still. V1F is negative 55. Was 0, but it's negative 55 this time because it's 55 down. V2F is 0. This time V2F is 0 because it's all horizontal. V3F is, picking up a different color here. What's V3F? Not 40, right? Because crossed out the 40. We're never going to use that again. Yeah, right? It's not negative 34. This one's positive 34. Now, I know that gets a little bit confusing, right? We made the 20 negative, and we're making the 34 positive. Well, the 20 was negative because the x was left. The 34 is positive because the y is up. Does that make sense? Plus V4F, and we solve for V4F here, and that V4F for the y component works out to be 20.359. And now we just combine them, that's all. We're going to say, oh, by the way, we kind of guessed that object number 4 was going up and to the right. Did we guess right? Did we guess correctly? Good? Yeah, we did, right? We got a positive x component and a positive y component. We guessed up and to the right, and we were correct. It is going up and to the right. Yeah? How come I wouldn't put the negative for the 20? Well, negative 55 plus 34 is negative 20, but then it goes over to the other side by adding, so it becomes positive 20. Does that make sense? Okay, so we got 100, and we got 20. And then we solve for v and theta. V is the square root of 100 plus 100 squared plus 20 squared. V is equal to 102 meters per second. And theta is the inverse tan function of opposite over adjacent, which gives me a theta of 11.5 degrees. Now, I think it was Mason that I saw had 79.5. Did we hit 79.5? What's the difference between those? 11.5 degrees measuring this angle from the east. So it would be north from the east or north of east. In order for Mason's to be correct, he would need to have it 79.5 degrees east of north, right? Because he just drew it differently than I did. Instead of drawing 100 then 20, he drew 20 then 100. And then he calculated his angle right there to be 79.5 degrees east of north. They're both right. All right, number 6 says a 200 kilogram bomb. This time it's moving with a velocity of 10 meters per second to the west. It explodes into 3 pieces. First piece goes west, second piece goes north of east, third piece goes, who knows? So we're trying to find. So look, this is what we got before. Before the explosion, we have a single object. We'll call it the total mass of 200 kilograms going this way. That's it. That's all I got. And then after, this is what I've got. An explosion point where we've got one piece that's going to the west. Oops, sorry, what have I done wrong here? I have this going to the what? I have it going to the east, right? So let's fix that up. Let's say over here, this is before. Let's say our total object is going this way initially with a velocity of 10 meters per second, a mass of 200 kilograms. And then this is my after over here. This is my explosion point. We've got a piece, the first piece still going to the west. It is a mass of 100 kilograms and a velocity of 90 meters per second. Piece number 2 is going north of east, 30 degrees. Its mass is 55 kilograms, and its velocity is 55 meters per second. And the third piece is probably going to go down here somewhere. Don't know exactly where, but we're going to guess down there. And it has a mass of, what's it going to be, 45 kilograms? Right? That makes sense? 45 kilograms? Okay, so let's take this 30 degrees off to the side. It's a funny angle. We don't like it. Let's get rid of it. 55 meters per second. My angle is 30 degrees. And let's draw an X and Y. This is X that we usually do in blue, and this is Y that we usually do in green. Okay, which trig function? Sydney, which trig function is going to be the X component here? Yeah, because it's the adjacent side, right? So we're going to say X is equal to 55 cos 30, and 55 cos 30 works out to be 47.6314. And the Y component, Erica, this is the, which side of the triangle is this, the Y component? Opposite, adjacent, or hypotenuse? Yeah, so we're going to use the sine function this time. It's going to be 55 sine 30, which gives me 27.5 meters per second. And then I box this off, just to make it different, right? To make it look a little bit different. And then I'm going to go back to my X and Y components here. Pi is equal to Pf. M total times V initial equals M1 V1F plus M2 V2F plus M3 V3F. Mason, why did I include an M times V here for the initial? Because in that last question I didn't, right? Yeah, it's moving before it explodes this time. The total mass is 200 kilograms. The initial velocity is negative 10 because it's going to the left, going to the west. What's M1? 100. V1F is negative 90. right? Because it's going to the west. 90 is all on the x-axis. M2 is 55. M2 is 55. Stephen, what is V2F for the x component here? Object number 2, x component. Not this 55 meters per second thing, because that's dead, right? Yeah, it's 47, and it's to the right, so it's positive, right? Correct? 47.6314 plus third object is 45 kilograms times V3F. Now, both classes this morning and this afternoon, I had people asking about this. How do you rearrange this? 200 times negative 10 is negative 2,000. 100 times negative 90 is negative 9,000. 55 times 47 is, I'm not sure. 55 times 47.6314 is 2619.727. Okay, take this over first by adding, then take this over by subtracting, and then divide by 45. Or you could have combined these two terms and then taken them over. But since the 45 thing is attached to the V3F, that's the last thing you're going to take over. When we do that, when we solve for V3F there, it works out to be 97.3394. Okay, there's our x component. And then I do the y component. Oh, I like the y component. Yeah, I like this. Tell me why. Tell me what it is about the y component that I like better. In this case, not always, right? But in this case, what is it about the y component? Grace, what do you think it is about the y component that makes it more appealing than the x component? Yeah. Good. Two of them, right? Two of them are zero that I can get rid of here. The initial momentum is zero, and the first object is also zero after the explosion takes place. Good. M2 V2F plus M3 V3F. All right. M2, the value of M2 is, what is it, 55? Yeah, 55 times V2F. One's gone. Object number 2, the 55 meters per second is irrelevant. Zach, what am I going to use for V2F here? V2F for the y component. Yeah, good. We're going to make it positive as well because it's up. Plus M3, 45 times V3F. This one's easier to solve for, right? V3F works out to be for the x component, for the y component here, negative 33.611. And now it's physics 20, math 10/physics 20. 97, 33. Solve for V, solve for theta. V is the square root of a squared plus b squared, 103. And theta is the inverse tan of opposite over adjacent. We get 19.0 degrees. And that would be, look, we're measuring it from the east. But it's south from the east. So we would say south from east or south of east. How many people ended up getting that?